Welcome to the first lecture on practical implementation of network coding. We have today the very nice introduction of network coding, which is very easy for you. Just to introduce the team, you will see Juan here and also Zuo. Both of them will help also with the exercises later on. And if you have any questions, please go to the web page with all the different rooms numbers here, as you can see. So what we would like to do with the lecture is, of course, we would like to explain you the network coding, what it is, right? And there is a little bit part of the theory, and there is part that is really hands-on. Here we really would like to look into the hands-on. There's another lecture where you also have a little bit more theory on that. And we would also like to show then how network coding relates to the new things in 5G and storage, right? The hands-on is so important for us because we think that the practical part only can be done if you understand how to program with that. I think that we already introduced to you to Kodo. For that we need a license. Who of you have already applied for the license? Some of you, right? So very good. We need to install some stuff that will be done by Zuo and Juan later. Important for us that you understand why the implementation is so interesting. There are always some theoretical questions that we have, and once you have solved those, we would like to bring it to the simulation, software in the loop and hardware in the loop part. And once you test it out, you will see there will be some bottlenecks or something that you cannot optimize anymore. And that means you have to go back to the whiteboard and do the theory part. You will see some of the examples, right? We call this the research methodology, a theory that matters. And why it is so important, it shows you exactly what network coding did, right? There's some sort of network coding called random linear network coding. We will hear about this later. And here you see that we had some throughput, some coding throughput over some number of packets that we coded together that was quite low in the beginning, right? This was 2007. And just by doing improvement on the implementation, you would never speed this up. You can look for hardware acceleration, etc. But this will give you factors 5 to 10 maybe to speed it up. But going back to the whiteboard and really look into the theory, what we have achieved, let's say after 5 years, is factor of 200. If you want to understand where the coding speeds are nowadays, there is a tool called Kodo only for Android users. Here's the QR code. If you want to just download it, test it, you will see then for different coding setting how fast we can do the coding today. And this was a big achievement for us to be that fast, and I'll tell you a little bit how this works. For the next lectures, I think we have 3 basic pillars. One is really deterministic codes and network coding, then the analog network coding, and later the random linear network coding. And only the last pillar is that what we are interested in. The other 2 is just to understand network coding in a better way, in a very quick way. There are a lot of illustrations that you can use. For implementations, they are not so important, but it's very nice to understand where it came from and what you can do with it. Most of the publications that you will find on IEEE Explorer, for example, are on the first one. Deterministic codes, some simple XOR type of codes, but the real work is down here on the random linear network codes. Analog network coding is also a nice toolbox, but there's a lot of things to do. We actually do not do so much implementation on this part. We are more on the later part, as you will see. Okay, so why do we think network coding is so important? If you come to Communication Network 3, we always talk about the 5G atom where we have 5G use cases. And these use cases nowadays don't only look for higher throughput, they also look for latency and also resilience and security. And how can you do that? In standard ways to achieve low latency and high resilience and high throughput, that's pretty hard. You will learn here how network coding can help you for this kind of technical requirements. It will also show you how new concepts like mesh will, for example, will help where network coding can help here, right? One of the works that we have done, you can see it here, is done by Krishna, Simon and Frank. They are looking for multi-pass mesh networks. Normally mesh networks have a single pass. Here you see a drone. It's a game in emulated world where you fly a drone through a city, either with the standard way. On the right side you see the legacy routing, and on the left you see the mesmerized. And on the left you see multiple passes, and that is not so easy. If you have seen Communication Network 1, where we explain you the work of Paul Barron, and you say a single pass is quite vulnerable, but multiple pass will eat up the capacity. And this is a solution done in network coding. And it's not only an emulated, you also see here they're flying the drone over a field where we have one flying drone and multiple access points, and you see how the different communication passes are there with network coded devices. So all in all, I think more on this 5G atom you will learn on Communication Network 3, but important is to understand there will be a trade-off of latency and throughput and resilience, and we would like to look into that.